mission specialist Dr. Steve Hawley, who will be deploying the Hubble Space Telescope. Marine Colonel Charlie Bolden, the pilot for the mission. Air Force Colonel Lauren Shriver, the mission commander. Dr. Catherine Sullivan, mission specialist. And Steve McCandless, Navy Captain, Bruce McCandless, mission specialist for STS-31, our 5 flight crew members. The mission emblem on the cake on the breakfast table, which is Discovery with the Hubble Space Telescope on a field of planets, stars, and galaxies. This is shuttle launch control at T-minus 3 hours and holding. Approximately 9 minutes remaining in this built-in hold. We are watching the astronauts suit up. This is Commander Lauren Shriver having his helmet attached. Shriver is an Air Force colonel and is the mission commander. There's Marine Colonel Charlie Bolden, the pilot, also having his helmet and communications attachments completed. There is Navy Captain Bruce McCandless. McCandless and Kathy Sullivan will be doing the contingency EVA on this flight should one be necessary to support Hubble Space Telescope operations in the event some anomaly should occur, such as a lack of solar panel deployment or some other problem which could be corrected by the crew before the telescope is deployed. Here's Dr. Kathy Sullivan awaiting the helmet attachment. Otherwise, her suit-up is essentially complete. And Dr. Steve Hawley ready to go. He will be operating the remote manipulator arm to deploy the Hubble Space Telescope on Flight Day 2. This is shuttle launch control at T-minus 2 hours, 56 minutes and counting. Going now to the astronaut quarters. The crew now headed for the elevator that will take them down to the first floor, where they'll board the Astrovan for the 20-minute ride out to Pad B. The commander and the pilot, Commander Shriver and pilot Charlie Bolden, Bruce McCandless. This is a view of the orbiter access arm, and we can see our 5-member flight crew crossing from the fixed service structure into the White Room. There's Commander Shriver. Check of his glasses. Shriver is 45 years old, a colonel in the Air Force, selected as an astronaut candidate in 1978. He flew previously on STS-31C in 1985 on a 3-day Department of Defense mission. We're seeing astronaut Charlie Bolden being assisted now with his gear. He is 43 years old, a colonel in the Marine Corps, selected as an astronaut candidate in 1980. Next to enter will be Bruce McCandless and Kathy Sullivan.
OTC, OVCC. Go ahead. Yeah, our last crew members boarding at this time. Copy that.
This is shuttle launch control at T-minus 1 hour, 36 minutes and counting. We're approaching sunrise at the Kennedy Space Center. And we're looking at the Space Shuttle Discovery on Launch Pad 39B. The Hubble Space Telescope is in the payload bay with the payload bay doors closed at about 10:15 on Saturday night. We'll run a video now that shows Hubble Space Telescope processing at KSC. This is the vertical processing facility where Hubble was taken on the 4th of October. The telescope here shortly after arrival in the clean room in the horizontal position. Now being rotated to vertical. The two black antennas are the S-band communications antennas with the tracking and data relay satellites. Telescope now vertical. There are once again the S-band TDRS antennas. There are the solar panels attached to either side that will be deployed before releasing the telescope. Those are the attached fittings into the payload bay. One of the remote manipulator arm docking targets. And here are the technicians preparing the telescope for installation of the protective cocoon, which will go over the telescope to provide contamination protection during the 6 months that it will be undergoing testing.
All right, IPR on line item 80 has been updated. PR is now line item 81.
At the very top, there is a cover over the aperture door, which remained on the telescope until shortly before closing the payload bay doors for the first launch attempt. Again, the communications antennas, the pair of solar panels, the RMS docking targets, and below the service bays of the telescope that can be accessed by the astronauts to do any repair or refurbishment activities. This is the installation of the protective cocoon over the telescope. About 2/3 of the way through the flow, the liner was changed. During that time, there was a final contamination inspection, which is what we're witnessing there, a sample being taken. In December, the wide field planetary camera arrived from Jet Propulsion Laboratory, and here we see the installation into one of the service bays of the telescope itself. Overview of the wide field planetary camera. This is the protective cocoon. It's shipped into KSC on a roller, suspended over the telescope, and then pulled down around the spacecraft. And here is the cocoon being lowered. This is preparation for shifting the telescope now in its protective cocoon to an adjacent test cell so that it can be placed into the payload canister for transportation to the launch pad.
Good morning, OTC, MS2. Was with you. We're ready.
After the telescope is in position in the test cell, then the payload canister will be moved into place directly in front of the telescope for the installation activities. And in these pictures, it's very obvious why they term that a cocoon. Here is the canister now that has been moved into place, transporter beneath it, which will take it out to the launch pad, which occurred at the end of March. Preparing now to move the canister back away from the test cell with the space telescope installed.
Good morning, NGD. This is MS2. Contact. Good morning. Your line clear out. Thank you.
Doors being closed for transportation to the launch pad, and here in the payload changeout room, gantry-like white room facility adjacent to the payload bay. Here's a final cleaning of the telescope after the Cocoon has been removed.
All systems on channel 212, this OTC.
And this is the beginning of the installation activities. Telescope is extended on the payload ground handling mechanism, which is an extension device, a telescoping extension device, which can be moved forward, placing the telescope into the payload bay, and it will be locked into place by 4 retention latches. The payload ground handling mechanism being retracted, and the payload bay doors being closed prior to the first launch attempt.
OTC to 1. Go ahead. Yeah, per the clock.
This view from the flight deck, observing the port door being closed. With the payload test team below. Telescope in the payload bay at launch will weigh 22,322 pounds. And the starboard door coming closed.
That's affirmative, OTC, we're ready. Okay. All systems on channel 212, any conversation?
And of course,
channel 212 during AstroCom.
the doors were reopened later to remove the Hubble Space Telescope batteries to take them back to the battery lab for recharging during the stand down.
For air to ground 2, ICOM A, ICOM B, air to air for comfort, and do not change audio panel switch configuration. OTC, OVCC. Go ahead. Yes, sir. Hatch closure is complete. Leak check is good. Continuity check is good. We're ready for 2 PSI depressurization. Copy. Did you D as well, I assume? That's affirmative.
Among the turnaround activities over the past week has been the removal of the batteries from the Hubble Space Telescope, and we will show you a video now of the activities surrounding the batteries. Here they have just been removed from the payload changeout room and have been placed on transportation carts to be taken down the elevators of the fixed service structure and taken to an awaiting truck for transportation to the battery lab, which is located in the vehicle assembly building. This occurred last Saturday night.
What's that, Jerry?
Each set of batteries, there are 2, there are 6 batteries in each set, and the set weighs about 400 pounds. This is the removal of the batteries from the payload changeout room and heading toward the elevators. This decision was made because the batteries can be charged in a colder environment in the battery lab than they can in the telescope on board Discovery. If these batteries are dropped to a temperature of 32 degrees Fahrenheit, then they will take on a charge very readily, and we would get more charge than we could get in the payload changeout room. We can supply a purge to the batteries of about 45 degrees while they're in the telescope in the payload bay, but if they're taken to the battery lab, then they can be dropped to freezing, where nickel hydrogen batteries charge easily and a full charge could be obtained, where in the time available probably not a full charge could be obtained at the pad under a 45-degree purge. The bottom line is that this gives us an extra day of contingency should we need it. We would have launch attempts through Saturday as far as Hubble Space Telescope is concerned, so as compared to our first launch attempt where we had 4 days, with our batteries now fully charged, we have 5. The batteries are a bridge between disconnecting the HST to orbiter umbilicals for deployment and the time that the solar panels are actually deployed on the telescope. Batteries also supply power while the telescope is in eclipse on the dark side of the Earth. This is the transfer aisle of the vehicle assembly building, and here you can see the truck arriving with the batteries for transportation to the lab.
Go ahead. Stand by to perform scan and leak check. Yes, sir. Okay, panel L2A1. Go ahead. And it's Van Nuysel switch.
There's nothing unusual about the truck in which they're transported. It's a standard delivery truck.
And we're configured now. ECL. I can verify 650. Okay, you can perform your crew module for initial cabin 2 PSI leak check. Proceed with 45 ECL.
Total charge time on the batteries while they were in the battery lab was 130 hours.
And CDR to notify ECL cabin pressure master alarm. Cabin oxygen master alarm also down due to high cabin decay rate.
Yeah, CDR, you copy that?
The payload bay doors of Discovery were closed during the battery charging activity to provide a very clean environment for the telescope. Class 100 air can be circulated around the telescope while the doors are closed. Much of the activity over the last week has been associated with changing out Discovery's #1 auxiliary power unit, which was removed last Saturday and sent back to the vendor for analysis. A new one was on hand and ready for installation, and we have video of that unit being prepared for transportation to the launch pad.
Discovery Houston, SIMO air-to-ground voice check, steady rate.
The auxiliary power unit which presented the problem was found to
After that, MS's 1, 2, and 3.
have a chip in one of the valves that's involved with regulating the flow of hydrazine. Therefore, what we found was a one-time hardware problem
MS3.
and not an overall design or engineering concern. This is the replacement auxiliary power unit being prepared for transportation. In the back, there is the one that was taken out and was shipped back to the vendor for analysis.
Altimeter setting of 30.
That is the aft area of Discovery where the replacement auxiliary power unit will be installed, and adjacent is the external tank and the solid rocket boosters.
Now what we're working, manual right now is a single string for tack ends.
The replacement
We're planning on going
unit was
into rear orbit.
transported to the pad on
Both of those,
Saturday and was connected
possibility of a 3,000.
on Sunday. Most of that work was completed in time to give most of the
Basically all 3 tack
team the rest of the Easter Sunday period off.
primary tack end back up again. We may yet declare banjo.
After the installation, the replacement auxiliary power unit
AOA.
was hot-fired, was run for a little over 5 minutes to verify that there
Our primary
would not be a repeat of the problem that we had before,
we have
and to give it the same amount of runtime as the other auxiliary power units which are on board Discovery. And that test went fine.
Okay, Steve, we copy. And CDR OTC, air to ground 1.
This now is going into the aft area for the installation.
That's inward.
In parallel with this activity, the payload bay doors of Discovery were closed and the batteries for the Hubble Space Telescope were back in the battery lab being charged.
PFS is an Ops 1, no unexpected messages.
Copy that, thank you. And PLT, OTC?
Go ahead, Sam.
Okay, configure pass and BFS horizontal SIP displays per your checklist, please.
Commander Schreiber has reported that the backup flight system is now in the proper mode. And we just saw astronaut Dan Brandenstein flying the shuttle training aircraft, doing the weather reconnaissance and assessing the conditions at the shuttle landing facility in the event of a return to launch site abort. He's reporting that data to support astronaut Ken Reichler and astronaut Jim Weatherby here in the firing room.
OTC, CVFS.
Go ahead.
T-minus 20 minutes, CPC dump is complete.
Copy that, CMQC is 979. Copy 979.
T-minus 12 minutes and counting, we've received word from White Sands that the weather reconnaissance aircraft there has advised that with the wind that they're seeing, there is still ample margin out there to cover any contingency in the event that we should have an abort once around. He has reported his observations to the chairman of the mission management team, Brewster Shaw, and Brewster has determined that weather at White Sands is go for launch.
This is NTD on 212, taking a status check for launch. Say go, no go for launch. OTC? Go. TVC? Go. PTC? Go. LPS? Go. Flight? Houston Flight, NTD. Maui? Maui, NTD. STM? STM, let's go. Safety console.
Would it be legal to call my lady?
Safety console.
Now about 2 minutes into the T-minus 9-minute built-in hold. We'll go now to Mission Control in Houston for a readiness statement and also to the Space Telescope Operations Control Center at Goddard. They will report their readiness. Going now to Mission Control in Houston.
This is Mission Control Houston. Flight controllers in the Figure 1 room are ready for launch. The flight director for Ascent, Von Dittemore, just polled the room, and all positions reported they will be go for coming out of the T-minus 9-minute hold. One slight change to this morning's plans for launch. Ben Guerrier will be designated as the prime transatlantic landing site with Banjul as backup due to a problem with the primary TACAN system at Banjul. The secondary TACAN system is operational, but since weather is good at both sites, we will be choosing Ben Guerrier as the prime transatlantic landing site this morning. No other systems problems are reported, and all positions in Mission Control are standing by for launch. This is Mission Control Houston. We'll hand over now to Hubble Space Telescope Operations at Goddard.
FM wheels, channel 118 X-ray.
This is Hubble Telescope Control Greenbelt. The Director of Orbital Verification, Mike Harrington, has confirmed that all control team positions here at the Space Telescope Operations Control Center in Maryland and the support team at the Huntsville Operations Support Center in Alabama are ready to support today's launch of the Hubble Space Telescope. Approximately 3 hours ago, the crew configured switches aboard the orbiter to provide essential power to 3 telescope systems. The telescope's receivers were powered to ensure that they are warm and on frequency to receive initial commands from the control center following launch. Heaters for the rate sensing units were powered to maintain the gyros at a stable temperature, and power was applied to the fixed head star tracker shutters to ensure that they remain closed during launch. Otherwise, the telescope is essentially powered down in Discovery's cargo bay and ready for launch. Beginning approximately 4.5 hours after launch, controllers here will begin sending commands to systematically activate the telescope systems in preparation for tomorrow's scheduled deployment. Again, all is ready here in the control center at Goddard Space Flight Center, Greenbelt, Maryland, and at the support center at the Marshall Space Flight Center in Huntsville, Alabama, for today's launch of the Hubble Space Telescope.
T-minus 7 minutes, 30 seconds and counting.
CLS's go for orbiter access arm retract.
In about 45 seconds, the orbiter test conductor will give pilot Charlie Bolden a go to perform the auxiliary power unit pre-start. Bolden will configure switches in the cockpit to put the APUs in the ready-to-start configuration.
And OTC, PLT, APU start is complete, and so far so good.
There are the good words, 3 APUs in good health. Final purge sequence of the main engines is in work. We're now transferring to internal power and switching off the orbiter's ground power supply. Standing by now, here is the retraction of the gaseous oxygen vent hood. Gimbling of the main engines is complete, and the aero surfaces have been verified that they are positioned for launch. The external tank now is reported to be at flight pressure.
OTC 212, close and lock your visors and initiate your O2 flow, and you all have a good trip.
Roger that, 10 work.
SDE, this is CMTS. We're going to make an attempt to first with that valve closed. We've got the prereq set off. If this works, we should be in good shape. I copy. Proceed. It work.
We have 7 minutes of runtime available on the auxiliary power units. We've been holding now about 2 minutes and 20 seconds.
NTD, this is CMTS. The valve is closed. We'll go.
There's the confirmation that we have successfully
you're in the
recycled.
the pickup terminal sequence MPS. That's affirmative, so we'll go. We're in good shape. Okay, you have a go to proceed. GLS, pick up the count immediately.
I copy. Mark. CLS's go for auto sequence start.
We are go for start.
25.
Booster hydraulic power units have started.
20.
Sound suppression water system has started.
15.
T-minus 13 seconds.
10.
T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program.
Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling back. The throttle down maneuver assists in reducing the aerodynamic loads on Discovery as it passes through the area of maximum dynamic pressure. Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Discovery, go at throttle up.
All 3 engines now throttled back up.
Go throttle up.
Engines at 104%. The go at throttle up call signifies that all systems are performing well. All 3 auxiliary power units look good. Discovery's velocity now 2,300 feet per second and is downrange 8 nautical miles. Standing by for SRB separation. And both solid rocket boosters have separated. Discovery's velocity now 4,300 feet per second at a downrange distance of 35 nautical miles.
And this is Mission Control Houston at 3 hours 2 minutes into the flight of Discovery. We're now seeing payload bay views from camera A. That's on the forward bulkhead of Discovery looking aft.
Discovery Houston, we're getting some real good payload bay television downlink, and we see that Steve has been hard at work getting the RMS deployed.
Okay, I copy. And you want those done now?
You can do the ones that are going off on time.
Okay, I'll do the ones going off on time. Boiler controller number 2 is going to Bravo.
Okay, Charlie, thanks, and we'll let you know if this one works.
And this is Mission Control. We're now looking from payload bay camera B straight up at the end effector of the remote manipulator system arm as the end effector goes through its checkout.
Roger, Charlie, we concur, and your go to begin your depress.
This is Mission Control Houston at 4 hours 22 minutes. The crew's been given the go to begin the...
And Bruce, you can take the airlock depress valve as soon as she's complete with that to 5.
The crew's been given a go to depress the cabin from the 14.7 psi level to the 10.2 level, as we are seeing payload bay views from the remote manipulator system arm as mission specialist Steve Hawley does a photo survey of the Hubble Space Telescope.
Now in the field of view one of the two grapple fixtures mounted to the Hubble Space Telescope. One of these fixtures will be used by Steve Hawley tomorrow to grapple the telescope with the remote manipulator system to lift it out of the payload bay.